Good morning, periods 2 and 3 calculus class. This is Miss G and it's Wednesday, March 25th. Hope you're doing well today. I'm going to start with the answers to the two problems I gave you yesterday. So let's see, what are we looking at here? Here was the first one. The integral of 5x squared minus 1 to the fourth power times 10x dx. We were doing u/du substitutions, so we look for the inside function, which is 5x squared minus 1. That becomes u. We take the derivative of that, we get 10x dx. So now we substitute. We can see that u takes the place of 5x squared minus 1. We still have the fourth power, and then the du will take care of the 10x dx. So now all we have to do is integrate u to the fourth power. We add 1 to the exponent, we get 5. We divide the coefficient of 1 by the new exponent. We get 1/5 u to the fifth plus c. And then we put our x's back in. So we get 1/5 times the quantity 5x squared minus 1 to the fifth power plus c. And then I asked you to check it yesterday, so here we go. We take the derivative of our answer. So we have 5 times 1/5. Keep the base the same, subtract 1 from the exponent, get 4. Take the derivative of the inside function, we get 10x. Plus the derivative of c, which is 0. All right, so then what does that give us? 1, 5 times the fifth is 1. 5x squared minus 1 to the fourth power times 10x. And voila, there we go. 5x squared minus 1 to the fourth power times 10x is our original integrand, so that checks. Okay, I hope you did well on that one. Now the other one we did last night is the integral of the square root of 3x to the fourth power plus 9 times 12x cubed dx. The inside function here is 3x to the fourth plus 9. That's our u. Take the derivative of u, we get 12x cubed dx, because the derivative of 9 is going to give us 0. All right, do our substitution. 3x to the fourth plus 9 is replaced by u, raised to the 1/2 power because of the square root, and the du takes care of the 12x cubed dx. So this integral expression says the same thing as the original. Now we integrate. Add 1 to the exponent, get 3/2. Divide 1, the current coefficient, by 3/2, we get 2/3, plus c. Then put the x's back in for u. So we get 2/3 times 3x to the fourth plus 9 to the 3/2 plus c. Now let's check it. So we take the derivative of the answer, and we get, here's our answer, 3/2 times 2/3. Keep the base the same, 3x to the fourth plus 9. Subtract 1 from the exponent. 3/2 minus 1 is 1/2. Take the derivative of the inside function by chain rule. We get 12x cubed, plus the derivative of the constant, which is 0. Now simplify. 3/2 times 2/3 is 1. 3x to the fourth plus 9 to the 1/2 times 12x cubed, which is 3x to the fourth plus 9. That quantity to the 1/2 power times 12x cubed is our original integrand. So it works. All right, I hope you were successful on those two problems. We're going to take the u/du substitution integration a little farther today. So we're still in section 5.2, but we're going to throw in a little challenge, a little bit more challenging today. So same sort of process. We're still integrating by substitution. We still look for the inside function. Here's my example. 3x minus 2 to the fourth power. Our inside function is 3x minus 2. Now we take the derivative of 3x minus 2, and we get 3 dx. But guess what? There is no 3 as a coefficient in front of this quantity right here. So this 3 does not appear in our problem. That's not the same as the 3 over here. This 3 in the 3x minus 2. That's a different 3 because we took the derivative of 3x minus 2 to get this additional 3, which does not show up in front of the parentheses here. So we have an extra number that we don't want in our problem. Let's see why we don't want it. Because before we look at the 1/3 over here, we have u to the fourth power. Now we're going to substitute just like we did before. Our 3x minus 2 is our u. So that gives us u to the fourth. Then we put the du in the problem. We need the du. We need the integral sign in the du. But now the du is representing 3dx. And we don't need the 3 times the dx. We just need the dx because we have 3x minus 2 to the fourth times the dx. We need to get rid of the 3 that's multiplied. So what we're going to do is multiply that 3 by the reciprocal of 3, which would be 1/3. So we're going to put that 1/3 in front of our integral. Because 1/3 times 3 will cancel out the 3 and give us 1 dx. And then this problem will be equivalent to the original statement. So what did I write over here? 3 is not in the original problem, so multiply the integral by the reciprocal of 3 and put it in front of the integral symbol. All right, so now where does that bring us to? We still have the 1/3 we just put out there. We're integrating u to the fourth du, and so we add 1 to the exponent, which gives us 5. We divide the coefficient, and now we'll just consider that there's a 1 here. We'll ignore the 1/3 temporarily. So 1 divided by the new exponent gives us 1/5. And now we can take the 1/3 and we're going to multiply it by the 1/5. And of course we have our plus c. So we'll get 1/15 u to the 5th power plus c. And again, we put the x's back in for the u, and we get 1/15 times 3x minus 2 to the 5th power plus c. That's our answer. Now let's check that and show that when we take the derivative of this, we get the original integrand back. So here's the check. The derivative of our answer. So now we're going to multiply 5 times 1/15. Keep the inside function the same, 3x minus 2. Subtract 1 from the exponent gives me 4. Take the derivative of the inside function, which is 3. Let's simplify that. 5/15 gives me 1/3. So we have 1/3 3x minus 2 to the 4th power times 3. But the 1/3 cancels out the 3. And then we have 3x minus 2 to the 4th power. Oh, and I forgot to mention the derivative of c is 0, but we knew that. And 3x minus 2 to the 4th power is the original integrand. All right, I'm going to do one more of these and hope that you can catch on. All right, so here's this one. So we look for the inside function again in our integral, which is x times the square root of x squared minus 1 dx. So the inside function is x squared minus 1. The derivative of that, x squared minus 1, is 2x dx. Well, the x dx is fine because the x dx is in the problem. But we picked up a 2 that's not in the problem. We don't want that 2. We have to get rid of it. So we're going to take the reciprocal of that numerical coefficient and we're going to put it in front of the integral. And the reciprocal of 2 is, ta-da, 1/2. And I did write the square root, the radical as the 1/2 power. So this is just a rewrite here. But we don't want the 2 that's inherent in the du. Why? Because here, if I don't look at the 1/2 right now, the u represents x squared minus 1 to this 1/2 power, and the du represents 2x dx by our substitution. But we don't want that 2, which is why we put the reciprocal of 2 in front of the integral. We don't need to write all this stuff I have in blue here. We don't need to write that. I just did it to show you what the 1/2 does. It really does cancel out the 2 that the du represents, the 2 that we don't need. All right. So what we really need to write is just 1/2 times the integral of u to the 1/2 du. And then we integrate that. We add 1 to the exponent. 1/2 plus 1 is 3/2. Our coefficient, let's consider it just a 1 now. We're going to take 1 divided by 3/2, and we have our plus c. And we bring down the 1/2 in front of the integral. Now I have 1/2. 1 divided by 3/2 is 2/3. X squared minus 1 to the 3/2 plus c. 1/2 times 2/3, the 2's cancel, and I get 1/3 times x squared minus 1, that quantity raised to the 3/2 plus c. Okay, that's our answer. Now, I am going to take the derivative of this to prove that it worked. So, over here, the derivative of this answer right here is going to give me 3/2 times 1/3 by chain rule. Keep the base by the power rule version of the chain rule. So 3/2 times 1/3, keep the x squared minus 1 the same, subtract 1 from the 3/2, we get 1/2, and take the derivative of the inside by chain rule. That's 2x, plus the derivative of c, which is 0. Now, 3/2 times 1/3, the 3's will cancel and give us 1/2, times x squared minus 1 to the 1/2, times the derivative of x squared minus 1, which is 2x. The 2's will cancel, and therefore we're left with x squared minus 1 to the 1/2 times x, because the 2's canceled. And that is our original integrand. Whoop, where'd it go? Here. Okay, I hope you followed that. Maybe I went a little too fast, but you could pause it and take a look at my work. Again, if we pick up a number in our DU that we don't want because it doesn't show up in the original problem, just multiply the integral by the reciprocal of the number you don't want. And I want to sneak in here that we can only do it with extra numbers, numerical coefficients. We're not going to do it with x's or any variables. But for now, I'm just going to give you the ones with the numerical coefficient, and you're just going to multiply by the reciprocal out front. Okay, so I have a couple of problems for you to try. They're on page 329, number 19, 21, 23, 35, and 37. Okay, hope you do well with those, and I hope you have a great day.